Now let's try to find the average rate of change of the given three functions. Now it is given this fx is polynomial over here, and then in this particular interval. So you have to be very careful. You have to find to the particular interval. Here it is given closed interval 1, 2. Here also this is what trigonometric functions when x equals to 0 to pi by 2. Here f of x equals to e raised to x. This is exponential function. The interval here x equals to 0 to 1. Now let's solve one by one. Now what is definition of average rate of change of functions? We know that this is equals to average rate of change equals to what? Rise upon run, or you can say f of b minus f of a upon b minus a. Okay. Now this is solution for 1. Now fx is given. Now what is fx? My fx is what? X square plus twice x plus 3. In the interval what? 1, 2. So in the interval here a is what? 1 and b is what? 2. Now fx we have closed interval from 1, 2 we have. Okay. Now we need to find this one. Okay. Therefore let's find, in order to find this we need to find f of b as well as f of a. Therefore f of b means what? F of 2 equals, substitute 2 over here. Here you will get 2 square plus 2 into 2 is 4 plus 3 is equals to what? 2 to the 4. 4 plus 4 is 8, 11. Okay. And then what is f of a? Now f of a is what? F of 1 is equals to, here substitute over here x equals to 1 in this equation. Our fx is this. So what I am doing here, x equals to 2. I am substituting x equals to 2 over here in this function. Again here x equals to 1. Then f of 1 equals to what? 1 square plus 2 into 1 plus 3 is here. 2 here, 3. 3 plus 3 is what? 6. So we have f of 2 as well as f of 1. Therefore by this formula we have f of 2 minus f of 1 upon, here what is b? 2 minus 1 is what? F of 2 is 11 minus 6 upon 1 is equals to what? 5. 5 by 1 is same as 5. Therefore average rate of change of this function in this particular interval is 5. Okay, let's picturize it. Say for example we have here x-axis, y-axis. This graph goes like this. For example, okay, it's not exactly the graph which we are doing. For example, this. Okay. Now when a equals to what? When a equals to 1, let's say here a equals to b over here. Now here we have f of a. Here we have f of b. Okay. Now this, okay, therefore this is the, okay, therefore this secant, okay, this slope is what? This. Okay, how fast, okay, how fast the curve is going. Okay, this is given by average rate of change of the function. Now let's solve 2. Now f of x equals to, here it is given sine of x. F of x equals to what? We have sine of x. Now the interval is what? Let's consider a equals to what? 0 and b equals to here pi by 2. Now we need to find this. Now f of b is this, where we need to find f of b minus f of a. Therefore put x equals to 0. Okay. Here f of 0 equals to what? Sine of 0. So sine 0 degree is what? We know sine 0 is 0. Now let's substitute over here. X equals to pi by 2. Here f of b means f of pi by 2 equals to what? Sine of pi by 2. Sine pi by 2 is what? Same as sine of 90 degree. This same as sine 90 is 1. Okay. Therefore, this Therefore, this equals to what? By applying this formula, we have f of b means f of pi by 2 minus f of 0 upon pi by 2 minus 0. What is this value? Okay, this value pi by f of pi by 2 is what? 1. 1 minus 0 upon pi by 2 minus 0. Therefore, here 1 upon pi by 2. Therefore, is equals to, this 2 can go up, the same as 2 by pi. Therefore, 2 by pi is what? Average rate of change of this particular function sin x in this particular interval. Let's see graphically how it works. What is this? Now, you have to remember some formula over here. We have sine of x. We have standard 0 degree, 30, 45, 60, 90 degree. Sine 0 is 0. Sine 30 is half, 1 by root 2, root 3 by 2 and 1. Okay. This is the formula we have. This is the table we have. Standard table for sine x. Okay. Now, sine 0 is 0. This is for example x, y, 0. Now, let's try to draw this graph in this axis. When sine 0 is 0 over here, okay, this trace up to 1. This, for example, this is y equals to 1 here, y equals to minus 1 here. So, it's over here, okay. So, all the value, these are keep on increasing till 1, okay. So, therefore, the curve is like this, till 1, and then it will go oscillate like this, okay. Let's say here a equals to 0 over here, and here a equals to pi by 2. Okay. Now here when a equals to 0 over here, now 0, and then this curve will increases till 90 degree at maximum what? 1 over here, okay, here 1. So from here to here is the what? Average rate of change of function is this 2 by pi. Now, let's see this 3 number. Now, fx is given what? E raised to x in this closed interval 0 to 1. Let's see what is this graph. Now, we have what? f of x equals to say y equals to e raised to x. So, let's try to draw this graph over here. Say this is x-axis, y-axis. Now, let's plot over here x, y equals to e raised to x. When x equals to 0, so e raised to 0 is what? 1. Okay, when x equals to 1, e raised to 1 is 2.7 something. Okay. So, this graph, when x equals to 0, y equals to 1 over here. Okay. Here 1, here 2, here 3, here minus 1, here 1, 2, 3. When x equals to 0, this is over here. Okay. And then when x equals to 1, 2.7 is somewhere like this. Okay, so this graph is like this. Okay, keep on, it's exponential increasing. Okay, so e raised to x is always exponential, so exponential function is always increasing function. You can say over here. Okay, so 2.7 is somewhere like this. So here we have point over here, we have point over here. Now, let's come back to over here. Now, they are asking here what a equals to 0 over here and a equals to 1 over here. So, now f of x is given e raised to x. Then, here a equals to 0 and b equals to 1. Now, we need to find this. Therefore, average rate of change of function is what? F of b means what? We need to find f of b minus f of a upon b minus a is equals to f of b means what? F of 1 minus f of 0 upon 1 minus 0. Now, f of 1 is substitute over here. F of 1, if I substitute here e raised to 1 minus f of 0, if I substitute over here, e raised to 0 is what? E raised to 0 upon 1 minus 0. E same as e, let's write, minus e raised to 0 is what? 1 upon 1 is, we have standard value, we have, let's say 2.7 minus 1 upon 1. 2.7 minus 1 is what? 1.7 upon 1 is this. So, this is the what? This is the rate of change of this particular function in this particular interval. Means you can visualize over here, we have 0, a equals to 0 here, here a equals to 1 here. In this interval, this, okay, this is the rate of change of this secant is this, okay, is given by this.